Okay, hello and welcome everyone. In our last class, we started method of sections, which is a very common method used in order to determine the member forces of a truss. So I gave you a homework. I saw that couple of you have solved it, and some of you have mentioned that you didn't understand some points. So in this lecture, I will try to solve this truss. So whoever has the questions or have problems, please try to concentrate on this lecture. Hope you will understand method of sections easily. Please take a note that method of sections, you will get a problem in your exam from method of sections. So I would like to recommend that all of the students please concentrate on on today's lecture, because I will try to show um, two truths at least by solving and explaining the basic features of method of sections. Okay, perfect. So this truss is Warren truss. Okay, so if you look at the Podda bridge, you will see that in Podda bridge they have used this type of truss. So a combination of triangles. Okay, so this type of truss is called Warren truss. So the Warren truss, loaded as shown in figure, is supported by a roller support at C and a hinge at G. Okay, by the method of sections, you have to compute the forces in the member BC. So this member force you have to determine DF and CE. Okay, so let me mark it. Okay, so you have to determine PC, DF and C. These three member force you have to determine. So method of sections are very helpful in this case, because here it is not asked to determine all of the member forces. If it is said that, then it will be better if we use method of joints. Since we are asked to determine only three member forces, so in that case method of sections will be very helpful. In your exam, please concentrate what method I am asking to use in order to determine the member forces. So if I ask in the question in method use method of sections, then we have to use method of sections in order to determine the member forces. But if I don't mention any methods, then you are free to use method of joints or method of sections, but you have to use some understanding. Okay, for example, if in this problem it is a very bad idea if you use method of joints, because method of joints, we will see later on that in method of joints you have to uh, take out all of the joints and you have to determine the member forces consecutively. Okay, but in method of sections, you don't need to take out the joints, you have to take the sections, and the sections you will use where the forces are asked to determine. Clear? So uh, in case of truss analysis, okay, first we will determine the reactions. Okay, so we are seeing the C joint, we have a roller support. So we know that a roller support, we have only one reaction. So let me take this like this. Okay, and at G point it is hinge support, so I have one vertical reaction and one horizontal reaction. Correct. Let me mark it. For example, take it as CY, and here GY, and this GX. Good. Don't be confused that some of you may be asked that why I am taking reactions as in upward direction. Correct. So since this is the beginning course, we just assume that the reactions are upward. After calculation, if I see that the reaction is gotten as negative, then we will change our direction, so it doesn't matter. Okay, but one thing I am very much sure about the horizontal reaction. Why? Because look, if I have a 60 kilonewton in the positive x direction, and there are no forces in which is acting in the x direction, correct? So there is only one reaction, which is gx. It must resist the 60 kilonewton force, correct? So 60 kilonewton force is acting in the positive direction, x direction. So gx will obviously be 60 kilonewton, but in the opposite direction, because the reaction, by the definition of reaction, it actually opposes the incoming load. So I can write that Gx, it will be 60 kilonewton, and the direction will be must in this direction, because the force, only one force is acting in the x direction, it is 60 kilonewton here. So the reaction is 60 kilonewton in this direction. Now in the vertical direction, I have three forces and two reactions. So let me take a moment with respect to, for example, C point. So I will take a moment at C point. So summation MC equals to 0, and I will take clockwise moment as positive. Okay, fine. So I will take a moment at C point, so Cy will not come. Okay, what about 40? This 40 kilonewton force, it will create a anti-clockwise moment with respect to C, anti-clockwise moment. So since I'm taking clockwise moment as positive, so this 40 kilonewton, it will give me a anti-clockwise negative moment. So 40 into distance is 6, so minus 40 into 6. In our last class, I have explained that whenever you are taking the distance, always uh, take a force parallel to this force. So this force is like this direction. So I will take a line at this direction. So the distance will be the distance between these two lines. So it is 6 meter. Good. What about this 60 kilonewton? This 60 kilonewton, it will create a positive moment, clockwise moment with respect to C. So plus 60 times, what about the distance? So this force is acting this direction. I will take a line parallel to this force, this direction. So the distance must be distance between these two lines. So it is 6 meter. So 6 meter, right? Yeah, 6 meter. So it is 6. Okay. So what about this 80? So this 80, it is acting at D point, which is at the right side of C, and it will create a clockwise movement. So plus 80 into, and what about the distance? The distance, it will be half of 6 meters, so it is 3. That 100. So it will create a clockwise movement, obviously. So plus 100 into 6. So plus 100 into 6. Good. And I have only one for, okay, what about gx? This gx is acting like this direction. So this direction, it means it is passing through the C point, correct? So this gx, it will not create any moment with respect to C. What about gy? Yes, it will create a moment, and it will create an anti-clockwise moment, so it is negative gy. Negative gy into, what about the distance? 6, 6, 12 meter. So 12 equals to 0. So I will get a gy equals to So I will get Gy equal to positive 80 kilonewton. Good. So it will, since I have taken the direction upward and I get positive value, so the assumed direction is correct. So that's okay. So just write Gy equals to 80 kilonewton. Good. Now, in order to determine the value of Cy, I have to use summation Fy. Summation Fy equals to 0, and I will take positive in the upward direction. Okay, actually you don't need to do any calculation right now because it can be calculated very easily. How? For example, how many forces are in the downward direction? You have 40, 80, so 120, and you have a force 100, so it is 120 plus 100, it means 220. Okay, you have only 80 kilonewton force upward, so it means that in order to balance the structure you need more upward forces, otherwise the structure will not be balanced. So what will be the value of Cy? The value of Cy, it will be very easy. How much? 140. Correct? Because uh, you have 80 kilonewton downward, you have gotten a reaction of Gy 80 kilonewton upward, so it balance. So how many downward forces you have? 140. So Cy must be 140 to balance the structure. Good. Or if you want, you can show summation Fy equal to 0 on take the vertical forces. For example, minus 40 minus 80, uh, Cy will be upward, I have taken, so plus Cy, and minus 100 and plus 80 equals to 0. So these 80, these 80 will cancel out, and minus 100 and minus 40, it means Cy equals to 140 kilo Newton. The assumed direction is correct. So the reaction we have calculated. Now let's start calculating the forces. Okay, at first there are three member forces, correct? BC, DF and CE. We have to calculate. So in order to calculate the member force BC, how you will take a section, you have to decide on. So I can see that if I take a section like this, then this member force BC will cut down, and it can be easily calculated. In order to calculate the member force DF and CE, you have to cut the section like this. So this section 1, 1, and this section 2, 2. Okay, great. So if I consider this section 1, 1, the left side, okay, not right side. So left side of section, left side, okay, left side of section 1, 1. So if I draw the section, it will be like this. Okay, so it will cut down, so like this. and then this force will cut down. So okay, and a force like this. I'm taking considering or assuming, I must say, I'm assuming the member force is as tension. If I get negative value, then I will say okay, this will not be in tension, it will be in compression. Okay, like this direction. So what about the point? I have a 40 kilonewton force here. So this is 40 applied force at A point, and 60 kilonewton at here. Sorry. So 60 kilonewton like this. So this is 60, and this is A point, this is B point. Okay, correct. So this member force, this member force, this. So I have to calculate this member force BC. I'm not concerned about this one, but if I need this in order to calculate BC, I'll calculate that. Otherwise, I'll not. So write down the member force. This is F A C. Okay, and this is FBD. Sorry. So this is FBD. This is FBC. This is an inclined force, right? So in our last class we have seen that if you have an inclined force, you can easily resolve it into two components. How? So this is my member force BC. So I need this angle theta. If I know this angle, then I can easily, I will get one force like this, since the member for the when you have an inclined force, so this is an inclined force, so one force will be like this and one force will be like this. Okay, the angle between these forces will be 90°. So you have to assume these two forces in such a way that the another force, it must be vertical like this, and the angle between this force and this force, it will be 90°. Correct? Good. So I will say, so I will have one force like here, it is FBC. Okay, another thing is that you need this angle theta. So what will be the angle theta? This angle. So take a, so take tan theta. Tan theta equals to the height. So I will take this angle, right? Because you need a right angle triangle. So in this triangle, if this is for example D prime, so BCD prime triangle, you need tan theta. So lombo means perpendicular, it is 6, and the base, it will be half of 6 meter, correct? Because this is 6 meters, so it is also 6 meter. So you need BD prime, so it is 3. So theta equals to tan inverse 2. Okay, so this angle it will be 63.43 degree. So how much? This angle theta, it is 63.43. 63.43. So this FBC horizontal component will be FBC cos 63.43, and the vertical component, it will be like this, and it is how much? FBC sine 60, sorry, 63.43. Okay, Now, what force you need to determine? In question, it is said determine member force BC. Okay. So now tell me how you will proceed. Correct? If I take summation fx equals to 0, this FBD, FBC cos, FAC and 60 will come, and I have 3 unknown I cannot determine. Okay. What about summation Fy? If I take summation Fy, then I have only one vertical force and this 40, so I can easily calculate FBC. So you have to be very much cautious, and you have to see whether you will take summation Fx or summation Fy. Okay. So in this case, if I take summation Fy, there will be only one unknown, which is summation FBC. This force I need to calculate, correct? So summation Fy equal to 0, and if I take positive upward, I will see minus 40 and minus FBC sine 63.43 equal to 0. So what about FBC? So we can see that FBC will be negative. It means that the direction you have assumed is wrong. It will not be in tension. The member force in BC member, it will be in compression. Okay, good. So if we calculate sine answer, okay, 0.894, and I have 40. The 40 divided by 40 divided by answer, how much? 44.72. So 44.72 kilonewton. So how I will write? I will write, I have seen that some students just write C. They put minus sign, also they write C. No, write like this. FBC equals to 44.72 kilonewton compression. Write like this, okay, in your exam. So okay, one member force we have determined. Now let's move on the second, on the to calculate the other forces. Okay, we have to calculate member force DF and CF. So what I will do, I will take the right section. I will take the right section of section 2. So right side of section 2. So we will take the right side of section 2 too. So if we look at the right side, we have a triangle, and this force and this member force DE and this member force C, it will come. So let us draw the section. So this, we have a triangle like this, and it is there we have a reaction. This, we have a reaction. So what is the value of the reactions? 80 and 60 kilonewton. So this is 80 and this is 60. Okay, after that we have a 100 kilonewton force at E point. So 100 kilonewton force at E point. Okay, and what is the point? F. So now what forces will come? If you look, we can see that this member force FDF will come. We will assume as a tension. So okay, FDF, and then which force? This force FCE. Okay, and another force FDE. Okay, so this force, it is FDF, FDF. This force is FCE, FCE, and FDE. So FDE. Okay. So what about the angle? There is an inclined force. Okay. So if we look, this angle theta we have to determine. So we will take this triangle, and similar angle it will come. Tan theta equal to perpendicular 6 divided by base. Base is 3. So 63.43. So where is this angle? This angle is here. Correct? So this will be theta 63.43. Okay. What about we write here 63.43 degree. So this inclined force, at first we have to resolve it into two components. So if I resolve it, it will be like this: horizontal components, and there will be a vertical component. Okay, so this is vertical component. Okay, so what is the name of this? This is F D E cos 63.43. And what about this force? This force, it will be F D E sin FDE sin 63.43. Now the thing is that if you look, I took I have taken the perpendicular component and horizontal component in such a way that the angle between the perpendicular component FDE sin 63.43 and the horizontal component FDE cos 63.43 is exactly 90 degree. Okay, perfect. Now we have to determine the member force FDF and FCE. So FDF and FC we have to determine. So what we can do? Perfect. If I take a moment, because you know that this FDF is unknown, FDE is unknown, FC is also unknown. Three components are unknown, correct? So if I take summation Fy, then this FDE will come. So it will help me. So if FDE come, then what will happen? There summation Fx, from summation Fx, uh, we have two unknown horizontal component FDF and FCE. So what we can do, we have to take a moment at some point, so that there is only one force is unknown. If I take moment at E point, for example, summation M E equal to 0, what will happen? Just have a look. Why I am taking moment at E? Why not F? Because if I take a moment at E point, then this force FC, it will be 0, because it will not give any moment since it is passing through the E point, and FDE cos 63.43, it will be 0. FDE sin 63.43, it will be also 0. So only one force, it will give me moment, member force. Actually this member force FDF, it will not be 0, and it will give me a moment. Correct? So then I can find out the force, member force FDF. What will happen? So if I take a moment here and I'm taking clockwise moment as positive, so this member force, it is giving me anti-clockwise moment. So minus F dF into, what is the distance between them? The distance between them is 6 meter. So 6. And what about this 60 kilonewton? It will not give me any moment because it is passing through the E point. What about 80? It will give me a moment anti-clockwise, which is minus 80 into 6. 80 into 6. Any more forces will give me moment? No. So equals to 0. So I will get F d F equals to 80. Sorry, it will be negative 80. So ultimately I will get F dF equals to 80 kilonewton, and the member dF, it will experience compression. Okay, good. Now we have to determine the member for CE. Now what you can do, if I take summation Fx, then I know FDF, but I don't know FDE. So from summation Fx, there will be two unknown, FCE and FDE. So it will not help me. So first take summation Fy equals to 0. If you take summation Fy equal to 0, summation Fy equal to 0, and the upward direction is positive, what will happen? I can determine the FDE. Then I will take summation Fx and I will determine the member force Fc. So if you take summation Fy equal to 0, what will happen from this free body diagram? So this member force minus 100, it will come. This plus 80, it will come also. And what will come? Because it is I have to take the member force which is acting in the positive y direction, in the y direction. If it is acting in the positive y direction, then it will be positive. So there is only one force which is acting in the y direction, and it is acting upward, positive, plus F d E sine 63.43, sine 63.43 equals to 0. So you will get FDE. Although I don't need the member force FDE, because in the question it is not asked to determine the member force FDE, but I have no choice, I have to determine, because in order to determine the member force CE, I need to use summation Fx equal to 0. In that case, I have to know the value of FDE, this force. FDE cos 63.43. So what will be the value of FDE? So 20 divided by sine 63.43. Okay, sorry, sine 63.43. How much? Okay, so 20 divided by answer 35. So positive. Okay, 35 35.51 kilonewton, and it is positive, so it will be in tension. So the member DE, it will experience tension, and the assumed direction is correct. Okay, now the final force you have to determine, summation Fx equal to 0. Summation Fx equal to 0. Okay, positive. Which force will come from this free body diagram? FDF. So it is minus FDF. Okay, and which force? This plus 6 minus 60. and minus FCE, this force minus FCE. So minus FCE, and this is minus FDE, minus FDE, and then what? FDE cos 63.43 times, sorry, I'm taking not moment, I'm taking force, so only force will come. If it is a moment, then I will consider the distance. Okay, then any missing forces? FDF 60, then FCE, FD, fine, equal to 0. So if I put the value here, minus, what is the value of FDF? It is minus 80, correct? So minus 80, or minus 80 minus 60 minus FCE I have to determine. And what is the value of minus FDE? It is 35.51 cos 63.43. So what would be the value? Cos 63.43, okay, into 35.51, 29.34. So minus 29.34 equal to 0. So if you calculate, then you will see FCE equals to minus 10, minus 10, 60, 30, 70, so plus 10, sorry. So FCE equal to 10 kilonewton, and it will be in tension. So this way you can determine uh, all the member forces. So I hope the students who have problems understanding the homework, they understand how they can use the method of sections to solve the homework problem. Okay, thank you. So I will show you another problem and give you some more homework. Thank you very much.